안녕하세요. 저는 프랑스에서 온 세바스찬입니다. 아름다운 소울 레닷 포럼에서 발표를 하고 최영원입니다. So now that you know a little bit more about me, as you may know, I work on the Ceph engineering team for Red Hat as a principal software engineer, responsible for a lot of things at Red Hat, such as Ceph, integration of Ceph into Openstack, subject that we will be discussing today, Ceph and containers, Ceph and Ansible for the configuration management system piece. But today's presentation is about the integration of Ceph into OpenStack as part of the Red Hat products. First, well, what is OpenStack? As you can see from the last survey of the OpenStack Foundation, what we can see here is that OpenStack, is really dominating most of the cloud deployments out there. And it has been true for several years already, and it keeps growing and growing. From production platforms to development or pure POCs, OpenStack is really becoming the de facto cloud management platform solution for building clouds. Then this is the Red Hat view. What we did at Red Hat is we basically took this OpenStack framework and we made a product out of it. And so the product is called Red Hat OpenStack Platform. And what we basically do is we deliver an enterprise-grade solution, cloud solution, that will allow you to deploy any type of clouds from hybrid to public to private clouds. And all of that is, you basically get all of the benefits when you buy something from Red Hat, meaning that you get all the QAs, something that has been validated and tested internally by all of the Red Hat engineers, you get trainings, you get support, and this is a really enterprise-grade level. These are the basic components that you get when you get the Red OSP product. So at the very bottom, something that you might be familiar with already, we have the Red Hat Enterprise Linux operating system. And the distribution of OpenStack is everything else. It's everything that you get. So if we start with the infrastructure as a service layer, we have the first component we have is called Nova, which brings compute resources, basically virtual machines, CPU, memory. Then we have the block storage functionality called Cinder. Cinder provides persistent storage to virtual machines by attaching block devices. Then we have an image service called Glance, responsible for storing all of your application templates as images. It's just an image catalog. We have object storage with Swift, which is the equivalent of Amazon S3. It's a RESTful object store API that allows you to store data as objects on the cloud. Then we have a shared file storage project called the Manila. It's the real equivalent of, it's really similar to Cinder, but instead of providing block storage resources, it provides a file system. So it's a different kind of storage interface that you can access and consume as a distributed file system fashion. So it's really the equivalent of NFS or Samba or SFFS. Then to connect all of the pieces, of course, we need to have a network stack, and Neutron is responsible for this. Neutron has several plugins that you can use. The default one being open source it is Open vSwitch. But you have other plugins from different vendors that you can use to connect all of your virtual machines together and also expose them so they can be consumed by the external users of the cloud. We have a bare metal provisioning functionality from Ironic, which is basically responsible for bootstrapping operating system images on bare metal machines. On top of the infrastructure as a service, we have what we call infrastructure as a service plus, because we are like almost scratching the border of the platform as a service. So what we get is a monitoring with Ceilometer. We basically collect and gather metrics from the cloud, and we interpret them. So we can say which user is using, for example, most of the resources from the cloud for the last 2 months. So we collect and we get metrics from the entire environment. Then we have a data processing project called Sahara. It's more suitable for HPC environments and scientific environments. So you can run workloads like Hadoop. we have an orchestration mechanism called HEAT, and it allows us to basically describe our entire application stack as a template. So you build your template, you specify your images, your virtual machine, their size, with the flavor, the network they will be connected to, the block devices that will be attached, and then you run this template, and in the end what you get is your entire environment being deployed and up and ready to be consumed. And we have a component called Trove, which is responsible for providing database as a service. So it's basically an endpoint for databases that you get, and it's a database that you can access and consume, and it's not something that you have to manage. You have your own application. This application requires a database access to store data, records, and here you get it with Trove. On the side, we have what we call shared services with first identity with Keystone, basically providing authorizations, storing users, tenant, groups, endpoints. And the second one is the dashboard called Horizon. In Horizon, you have two different views, the first one being for users and the second one for administrators. So users are really autonomous and they have access to their own environment and they can freely bootstrap in virtual machines, create block devices, do their own developer work, basically. On the side, we have the development and management console called Tripolo. Tripolo is the open source project name, but from a pure Red Hat perspective, this is called Director. And Director here is, from day one, well, at least D0 if you want, responsible for bootstrapping your entire cloud platform. Moving on to a really important piece, and this is also part of the main subject of this talk, is the Openstack Storage. So as you can see here, and perhaps as from the previous slide, we have several ways, several interfaces to access and consume storage within OpenStack. The first one being block storage, traditional block storage with Cinder, brings persistent storage to virtual machines. Image storage, Glance, which uses a similar mechanism as Cinder. It's just images are stored as block devices. We have a file system interface with Manila, which allows us to just expose file system services onto virtual machines. And finally, we have the object store with Swift, once again equivalent of Amazon S3, allows us to store data as objects in the cloud with a RESTful API. So now moving on, now that we know all of the storage interfaces part of OpenStack, we're going to discuss why traditional solutions, storage solutions, won't work with your cloud environment. Typically, and as explained, we have several interfaces to access and consume storage. This means that you might end up having different storage solutions from different vendors. And since storage interfaces don't scale at the same pace, you might end up having an object storage that is pretty big and a block storage that is pretty decent and so forth. So in the end, with all of that, you have several solutions to manage, to maintain, to manage the life cycle, and it can be really painful for operational tasks and operators as well. So this is not really ideal. Then introducing Ceph, because we really believe that Ceph is the right solution to solve all of these problems. So the future of storage with Ceph. Traditional storage infrastructure look a little bit like this. Basically, when you require storage, you say, okay, I need, for example, 1 petabyte of storage. Then what you get on the traditional model is a big box with 1 petabyte. If you need more, then you have the ability to scale up, but then at some point the rack will be full, so you will have to buy a second box. And then everything, and you repeat this pattern. So you need to bring more engineers to operate these boxes. Users can access one or n box, but the main problem is that you can't really connect all of these boxes. You can't really merge or create a cluster of different boxes and access a single namespace. This is not usually possible. One other thing is that you're kind of locked with a vendor solution. Sometimes it's really difficult to get out and to move your data to somewhere else. So now what we have to understand is that the industry is really moving toward a new paradigm. Everything is changing because of the software-defined anything. And in our case, it's software-defined storage, where we effectively separate control plane from data plane. So we basically want to leave hardware to hardware vendors and software to, well, software companies, just like we do. So everyone keeps on focusing on their own businesses. With a software-defined storage approach, it's really easy because we use standards hardware. So the idea is that we are completely agnostic on which server you're buying, which disk you're buying. The idea is just to have a bunch of servers, and then we will install the storage entity on these servers, and they will get chained all together. In the end, all of the machines will appear as a cluster. Then on top of that, we separated the control plane. So the control plane provides an API endpoint, so you can access and consume the data depending on the storage interface that you're looking at. In-house, we have two products at the moment. We have Ceph and we have Cluster. But for this, we will be focusing on pure Ceph. So what is Ceph? Basically, Ceph is a distributed, highly scalable open source storage solution that allows us to store, consume, and retrieve our data through several interfaces: object, file, and block. So with that, we can already feel that we are solving the main issue that we have with Openstack. So this is an open source project that was really designed to scale. So at the moment, we don't have any issues running multi-petabyte clusters, so we are looking for more. And we have a really vibrant open source community, tons of users. As for Ceph specifically, we have a really unique thing inside Ceph, and it's called Crush. Crush is the placement algorithm. It is definitely what makes Ceph so unique, because it allows us to pseudo-randomly place objects onto a cluster on a computable fashion, in a way that we can always retrieve objects, no matter what's happening. Then when we acquired Inktank, the company behind Ceph, we built a new product called Red Hat Storage Ceph. And the goal of this product is to provide enterprise-grade, ready, software-defined storage solution. So now let's dive a little bit into Ceph and what it is, what it does. So this might sound like a really complex diagram, but actually it is not. So at the very bottom, we have what we call Redis. And Redis is really the foundation of Ceph, where everything is really happening. So replication, backfilling, self-filling, self-managing, everything is being done at the Redis level. And Redis is just the object store, because within Ceph, everything is stored as an object. Then on top of that, we have a library that we can use to access all of these objects. And on top of that library, we built 3 different components. And these 3 components are just 3 new storage interfaces to access and consume data from the Redis object store. So the first one is Redis Gateway, which is really the equivalent of Amazon S3 and OpenStack Swift. So it offers us the capability to store objects, store data as objects onto a RESTful API. Then we have RBD, which is Redis Block Devices. So RBD is divided into 2 functionality. First one is a VM plugin, so we can attach block devices to virtual machine from QEMU. And the other one is a host driver. So it's a kernel driver where we can map block devices to perimeter machines. It's really the equivalent of an iSCSI, if you want. And then finally, we have a file system interface, which is called CephFS. And it's just a distributed, well, not just, because it's a really hard problem to solve. And we have been trying to solve this distributed file system problem for more than 20 years already. And here it is. If it's not perfect, but it's really designed to scale, not like solutions like NFS, for example. And yeah, it's just really a new well, new good way to store file systems data. Now if we look a little bit at the features that we have for Red Hat Storage 2, which was announced during the last Red Hat Summit in June, we have a new installer based on Ansible. So we now use Ansible to deploy Ceph. It's the de facto tool we use to deploy Ceph on bare metal machines. Then we have a console that allows us to use the Ceph Ansible, so we can deploy clusters and manage their life cycle, manage upgrades from a unique console. So it's good to visualize what's happening, visualize the state of the cluster. And we can also see metrics like how many IOs are being performed at the moment, which pool is almost full, and other things like this. Then on the Rados gateway, which is the RESTful Object Store interface, I'm just going to pick the multi-site one because it's a really important one. It's an announcement of the previous version of the multi-site, which then allows us to have multiple regions and multiple zones within those regions. So you can easily have one region in the US, one region in Europe, one region in Asia, and then within those regions you can have different zones. And we can do this kind of things with a master-master setup. So we don't have any master-slave replication going on, it's pure master-master. On the RBD side, on the block device side, we have a new feature called volume mirroring, which allows us to replicate block devices from one cluster to another. It's a really good functionality, and it's really crucial for use cases like disaster recovery and multi-site deployments. Some of the tech previews currently, CephFS, the distributed file system interface, is ready in tech preview for RHCS 2.0, so you can start playing with it. On the Rados side, we spent a lot of time improving and optimizing the code, the Ceph code, just to make sure that Ceph will perform better on small writes, especially for really fast drives like SSDs or NVMe drives. And so now we are getting outstanding performance from these drives. Now let's talk about the real integration of OpenStack and Ceph. So as you can see here, once again, a survey from the OpenStack Foundation, the adoption of Ceph into OpenStack. And just like OpenStack is dominating cloud deployments, Ceph is also dominating most of the OpenStack deployments. So we're up to 57% of usage for Ceph, and what you see here is that the first two are open source solutions. So Ceph is really becoming the de facto solution when it comes to backing up the OpenStack environment with storage. So the unified story. I think you already understood now that with Ceph we are solving the problems that we have within OpenStack with the different storage interfaces. But this has been an ongoing effort, and this wasn't really trivial. We have been working really hard since the second release of OpenStack to make sure that Ceph gets the best integration into OpenStack compared to all the other drivers. Ceph has a really complete integration of all the OpenStack components, and this is what we're going to see just now. So once again, looks like really difficult, or really, really difficult, but it's not that difficult. So we have a Rados cluster with all of the Ceph components. We don't need to go through that. And we have Rados Gateway here. One of the main advantages here is that Rados Gateway can act as a replacement for OpenStack Swift. So instead of using OpenStack Swift, you can use Rados Gateway, the RESTful object interface, to provide RESTful object storage. Rados has the ability to connect to Keystone, which is the identity service of OpenStack, so you can do token validation, token revocation, and verify that a user that wants to store an object is ability to do so. Then when we have Cinder, Glance, and Nova, which all use the exact same driver. It's the librd driver. It's just a library that allows you to create block devices into Ceph and attach them as well. So Cinderglance and Nova are storing all of their content using block devices. We have Manila, which is using another interface from Ceph. So Manila is connected to an MDS server to provide the CephFS file system. And we have Ceilometer more recently. Ceilometer is divided into two. Ceilometer is the pure telemetry service that gathers and collects, but the entity that is responsible for storing metrics is called Gnocchi. And the default backend for Gnocchi is Ceph, so you're storing all of the time series, all of the metrics within Ceph. It's not supported yet, but it will be in the next version of the product. Now, obviously, we have two big products, one big OpenStack product, one Ceph product, and their integration is really tight at the moment. So, for example, when you get Red Hat OpenStack platform, what you get by default, included as part of the product, is 64 terabytes of storage for Ceph. So you can easily start playing with Ceph, just evaluate if Ceph is suitable for infrastructure, as just like a playground, as a sandbox. OpenStack has the ability to connect multiple drivers, so this is definitely not an issue. You can have a main driver, and then along with that, you can have Ceph next to it. Obviously, the Red Hat OpenStack Platform Director, our deployment tool to deploy cloud platforms, is ready to deploy Red Hat Ceph Storage as well as part of the product, and then make sure that everything is well integrated. So the director can deploy Ceph, can deploy OpenStack, and then connect them all together. So now we're going to dive a little bit on architectural examples and what we can do and how we can benefit from this really tight integration. So we have the concept of hyperconvergence here. Hyperconvergence is a really fancy name basically to say that we are co-locating compute and storage resources on the same machine. So now hypervisors are also becoming storage nodes. We already have that as part of OpenStack within Nova. If we want to do this, we need to have a really thin control of all of the resources. This can be done by using cgroups, NUMA, and CPU pinning as part of OpenStack. This is almost there, this is there, but the real enabler is container-based infrastructure. At the moment, if you don't use containers to do this, you will have to configure things like cgroups on your own to restrain Ceph processes and consumption. So by that, you make sure that there is no CPU starvation or memory exhaustion on the machine. So here's the hyperconvergence node in depth, and this is how it looks like. So at the very bottom, you have the Linux kernel responsible for everything. And I'm saying Linux kernel, but you can just picture this by Red OpenStack, not Red OpenStack, Red Hat Enterprise Linux. Then we have the KVM module, where we have all the virtual machines. Then we have a Docker engine responsible for bootstrapping containers. And as you can see, all of these processes, so all of the Nova processes from OpenStack and all of the Ceph processes are being containerized. Everything that you see here is a container. Even the virtual machines are being containerized, and within those containers, we have the QEMU KVM process running. Now, multi-site. Multi-site is really crucial, as it really allows us to recover from disaster, to have a really big scaling and elastic cloud. What we do here is we basically reuse our OpenStack stack that we have been developing for several years with the safe integration. What we do is we basically have multiple isolated OpenStack environments. So it's simple to deploy, and we don't do any stretched environment. So it's really easy for us to deploy a single cloud and then connect it to another one. The only thing that is required is to have the RBD mirror and daemon, the one that I described on the slide from the new features for RHCS 2.0. So with that, we will be able to replicate cinder block devices, glance images from one site to another. So basically, each site has each other's data. The replication is happening live, and yeah, everything's good. So yet another complex diagram. But what you have to remember and get out of this one is that we have 2 sites at the moment. We can have more. It's designed to scale, so we can add a 3rd or 4th site, depending on what you want to do. The main thing that we do here is we have Openstack controllers, Ceph storage on both sides. And these are independent, isolated Openstack environments. Nothing is being stretched out. The only thing that is shared is the identity mechanism and the dashboard. So by sharing all of this, we make sure that we have all of the users of the several clouds and the several sites available, and it makes the entire thing easier, actually. At the very bottom, we have the Ceph cluster, and we have all of the cinder pool and glance pool. So a pool in Ceph is an entity where you store data, basically. And these pools are being replicated thanks to the RBD mirroring daemon. Now, almost done. We have been also busy writing this book with Sean and Daniel, where you will be able to learn new things about OpenStack and storage in general, and how you can benefit and what are the benefits from running OpenStack clouds along with a Ceph storage backend. So come and see us at the booth, and we will be just delivering copies, signed copies even if you want. And that's all. With all of that, I'd like to thank you for your kind attention, and I still have 3 minutes, so I'll be happy to take questions. Thank you.